There is a planet more than 120 light-years away that may be one of the strangest worlds ever studied. It is larger than Earth, surrounded by a hydrogen-rich atmosphere, and appears to contain carbon-bearing molecules that scientists would not normally expect to find together in such a world. But that is not what makes it truly fascinating. The planet is called K2-18b. And when the James Webb Space Telescope looked at its atmosphere, it found something that forced astronomers to ask a much bigger question. Could a planet that looks nothing like Earth still have the ingredients needed for life? The answer is not known. And that uncertainty is exactly what makes K2-18b so interesting. K2-18b orbits a small, cool star known as K2-18. The star is a red dwarf, much smaller and cooler than our Sun. The planet itself is about 2.6 times wider than Earth and roughly 8.6 times more massive. But size alone does not tell us what kind of world it is. K2-18b sits in what astronomers call the habitable zone. That is the region around a star where temperatures could, under the right atmospheric conditions, allow liquid water to exist on a planet's surface. But habitable zone does not mean habitable. Venus is close to the Sun's habitable zone by some definitions, yet its surface is hot enough to melt lead. Mars is also near the outer edge of the Sun's habitable zone, but its atmosphere is far too thin to support Earth-like conditions. So K2-18b being in this region is only the beginning. The real mystery is what is happening beneath its atmosphere. When astronomers first studied this planet, they could not simply photograph its surface. Instead, they waited for the planet to pass in front of its star. As it did, a tiny fraction of starlight traveled through the planet's atmosphere before reaching Earth. That light carried information. Different molecules absorb different wavelengths. So by studying the missing pieces of that starlight, astronomers can work out what gases may be present hundreds of trillions of kilometers away. And this is where K2-18b became much more interesting. Observations from the James Webb Space Telescope revealed strong evidence for methane and carbon dioxide in its atmosphere. Those molecules matter because they tell us something about the chemistry of the planet. But then came an unexpected possibility. The atmosphere appeared to contain little ammonia. That may sound like a minor detail. It isn't. One proposed model for K2-18b is that it could be a Hycean world, a planet with a hydrogen-rich atmosphere and a potentially ocean-covered interior. In such a scenario, the planet could be completely different from Earth while still containing a large amount of liquid water. But there is a problem. We have never directly seen that ocean. We don't know whether K2-18b actually has a global ocean. We don't know what its surface or interior looks like. And we certainly do not know whether anything is alive there. The telescope is reading the atmosphere from more than 100 light-years away. That distinction is crucial. Because the next discovery created headlines around the world. In 2023, researchers reported that Webb's observation showed a possible signal associated with dimethyl sulfide, or DMS. On Earth, DMS is strongly associated with biological activity, especially marine microorganisms. That made the molecule extremely interesting. But interesting is not the same as evidence of extraterrestrial life. The original detection was tentative. Later analyses have questioned whether the signal was strong enough to establish that DMS is actually present. And even if DMS were confirmed, scientists would still need to determine whether it could be produced by non-biological chemistry under the conditions on K2-18b. This is where the story becomes more complicated. Because there is a dangerous temptation when looking at distant planets. We see a molecule associated with life on Earth. We see a planet in the habitable zone. And our brains want to connect the two. But science cannot make that jump. A biological signature needs to survive alternative explanations. It needs repeated observations. It needs chemistry that rules out plausible non-biological sources. And it needs evidence strong enough that different teams can independently reach the same conclusion. K2-18b is nowhere near that point. But Webb has still revealed something remarkable. The planet's atmosphere is not chemically boring. It contains methane and carbon dioxide. And those gases can help astronomers test different ideas about what kind of planet this really is. One possibility is that K2-18b is a mini Neptune, a gaseous planet with no solid surface accessible to anything like Earth-based life. Another possibility is that it belongs to a class of water-rich worlds with thick hydrogen atmospheres. And there is an important third possibility. The planet could be something even more complicated that current models do not fully capture. This is why the planet is so valuable scientifically. It sits in the awkward space between familiar categories. It is too large to be a simple Earth analog. But it is also much smaller than Neptune. Its atmosphere is thick. Its chemistry is intriguing. Its orbit places it in a region where temperatures might permit liquid water under some conditions. And yet we still cannot see what is beneath the clouds. That is the frustrating part. Webb can detect molecules. It can measure light. It can test atmospheric models. But it cannot simply look through the atmosphere and reveal an ocean. And it cannot tell us whether chemistry on a distant planet has crossed the boundary into biology. That question remains open. Scientists are therefore watching K2-18b very carefully. More observations can strengthen or weaken the evidence for particular molecules. Better atmospheric models can test whether the planet's chemistry makes sense without biology. And future observatories may eventually give us even more powerful ways to study worlds like this. There is another reason K2-18b matters. It is forcing astronomers to rethink what they mean by an interesting planet. For decades, the search for life often focused on finding planets that looked as much like Earth as possible. Rocky. Small. Temperate. But nature may not be so simple. Perhaps life, if it exists elsewhere, could inhabit environments that look completely alien to us. Perhaps some worlds have oceans hidden beneath thick atmospheres. Perhaps some planets have chemical cycles that have no exact equivalent on Earth. Or perhaps K2-18b is simply a fascinating but lifeless world. Right now, all of those possibilities remain on the table. And that is not a failure. It is the point of the investigation. The James Webb Space Telescope has not discovered aliens around K2-18b. It has not proved that the planet has an ocean. It has not confirmed a biological signature. What it has done is something more subtle. It has taken a distant point of light and turned it into a world we can begin to investigate. We now know that its atmosphere contains specific molecules. We can measure its chemistry. We can compare competing models. And we can ask increasingly precise questions about what this strange planet might actually be. More than 120 light-years away, K2-18b is hidden from human eyes. We cannot travel there. We cannot see its oceans. We cannot stand beneath its sky. But its atmosphere is crossing the enormous distance between that world and ours as light. And inside that light are clues. Maybe they will eventually reveal a new kind of planet. Maybe they will reveal chemistry we have never seen before. Or maybe, after years of observations, the most exciting possibility will disappear and scientists will discover that everything they saw can be explained without life at all. That would still be a discovery. Because the real mystery of K2-18b is not whether it is hiding aliens. It is whether a world so different from Earth can still produce the chemistry that makes life possible. And somewhere in that faint starlight, the answer may already be there. We just have not learned how to read it yet.